Hello, judges. My name is MacDonald, and I am the project manager for Team 5.
Hello, I'm Alecsander Silva.
I am Noella Masengesho.
Hi, my name is Tran.
Hello, my name is Namya.
We are excited to present our hackathon system to you. It's called BatchCheck. So our agenda for today, we're going to go over our solution and a few of its highlights. We'll go through the process flow for how the solution fits into the pharmaceutical processing environment. We'll go through the advantages of our solution and how it addresses the hackathon task. And how we are going to achieve that through hardware, as well as AI handwriting recognition. And then because we're going to be in a GMP environment, we also want to be mindful of the authentication requirements. So we have some ideas around the biometrics, like authentication process. We'll talk about qualification of the solution and some of the risks involved with that. And finally, we will close out with the implementation, how long it will take and how much it will cost. Next slide, please. So our BatchCheck solution is a AI handwriting analysis tool for the ability to quickly scan and check your current paper batch record process. It really provides an automated extra set of eyes that currently happens kind of informally, or maybe even with like an additional sign-off in a lot of pharmaceutical environments. And this is going to be really helpful to improve quality because you'll be able to catch any problems on your batch record contemporaneously. So instead of having to wait a few weeks for when that material is going to be shipped out to be able to catch the problem, you'll be able to do an on-the-spot correction. And since we're already going to be inspecting those batch records, we'll be able to skim off information that will be really important for any key insights or metrics that the plant operators are interested in. All this is going to be powered by hardware providers that are trusted in the industry, as well as the AI handwriting engine that we will discuss. And the great thing about this option is that there's no need for a whole MES and there's no plant-wide shutdown time. Next slide, please. So here's how the system is going to fit into the existing pharmaceutical operations. So our operators performing a processing step, a weighing, a blending, anything like that, they're going to be handwriting information onto the paper batch record. At that point, they can use a tablet to scan that record and get quick feedback. So once they scan the record, our software will check that record to make sure that it is accurate. And if there's an issue, say something was transposed or they didn't sign in the right spot, they can get a warning at that time and be able to correct it on the spot. If it is correct and complete, which it should always be, then they will get a confirmation of that being correct. But also we're able to skim that record now for the KPIs that we're interested in and be able to export those onto a dashboard for OpEx or any other teams on the site. But for the operator, once they have that scan and they get that feedback, they can continue on their process.
So to just address some of the objectives given to us in the original problem statement, the first objective was to improve quality oversight. So you could argue that a properly implemented and trained AI is more effective at noticing errors or details than a human. The second objective is real-time availability. So once an electronic batch record is immediately sent in an application of our choice, it's available in real time. The third objective was to avoid manual processes. So the entire system was designed to be automated, all besides a one-click image trigger and processing. So once you click that button to take a picture of the original paper batch record, everything else is automated. And the fourth objective was to simultaneously record on paper and digital applications. So a paper record is initially generated, and then after that, an electronic batch record is subsequently produced. So then some key advantages of our system. In an existing paper batch record, errors are not noticed until the issue arises, and that can be a couple weeks down the line, potentially when a batch needs to be sent out. but an AI can be trained to find any errors and signal that to the person that's on the job. In the existing paper batch record, key data is locked in manual form. So data on paper is very static and it can be very hard to track by eye, but AI analysis can skim for any KPIs and publish that in a usable format. On a paper batch record, there's potential for missing attachments, equipment checks, but integrated sensors can prompt the operator that something is missing or that something is wrong. And then finally, there's a potential for uncontrolled or out-of-date records, and essentially our AI system will be able to appropriately place everything in the appropriate storage bins.
So this project will include some hardware and sensors, among which we will be focusing on a document scanner. We will need a document scanner that we will use to scan the information that was already written on paper before. And we will need a process for AI handwriting recognition, which will be interpreting the information that is on paper. We will need the cloud storage where these files are going to be kept for future references. We will need a pen or stylus for writing and a touch-sensitive surface for display after the handwriting recognition sensor interprets the information. So next slide, please. How this system works, we have the paper batch record where this information have been recorded before, either on paper or in other like paper-based format. We will use an app, either using a tablet to scan this information, and the information will go up in the cloud storage. And where there is a process engine in the cloud that processes this information, and it will return this information in form of JSON, and this information will be configured on an electronic batch record EBR. Next slide.
All right, AI qualification and validation. So for an AI to be qualified, it must be able to identify and create the proper boundaries, read handwritten text, identify and create categories, as well as categorize the handwritten text to the appropriate section. For validation, the AI engine is required to perform these tasks with high confidence, to correctly identify and create the proper boundaries, to correctly transcribe the handwritten text, and also correctly categorize the handwritten text to the appropriate category or section. Next slide, please. An option that meets all of the qualifications with minimal configuration would be Google Cloud Platform or GCP Vision AI. Google Cloud Platform Vision AI has the optical character recognition or OCR feature to extract text from images, as well as handwriting. It is able to select the best boundary conditions for the text and read it, whether it is a paragraph, line, or number. However, you will need to write additional code to recognize category titles and category items, and to write the file into a JSON. An additional feature of the Google Cloud Platform is that it will automatically detect different languages, so it will be useful in multi-regional conditions. The cost of this system would be up to $7,500 per month for 5 million scanned pages, which may be a lot, but it is unlikely that you'll scan that much pages within the month. However, there is a downside to using the platform. So depending on what currency you want to pay, it may not cost 7,500 or the same amount. For example, if you decide to pay in euros, you would actually be paying a little bit more than usual. However, this is an advantage to other solutions like Amazon Textract because it is not geographically based, where an operation would cost maybe $2.10 per 1,000 units in North Carolina, as compared to $1.50 in Iowa. Next slide, please.
So once an electronic batch record is produced, it can be sent to a cloud-based system for storage. Two options are Firebase and Amazon. Firebase is a cloud-based system from Google. It is easily integratable with the Google AI Vision that we had just previously mentioned. The estimated cost of that per month is about $1,500 for 1 million units. Another option is Amazon. It is a little bit cheaper. That is why we had listed it. That is about $12.50 a month for about 100 terabytes. An upside of using both these systems is that they are available on multi-platforms. So it could be as simple as using iOS and accessing it from your iPhone, or something as simple as accessing it from your Android phone. And in both cases, we would institute a customer requirement so that we could set a hybrid cloud storage system that would meet our preferences. Next slide, please. And then just to touch upon the biometric security authentication, a security system using biometrics could be properly implemented to grant access software and cloud storage software to the appropriate personnel. This would alleviate any security concerns associated with password sharing or inappropriate uploads from unauthorized personnel at workbenches, since workbenches are essentially open access. And a system that could be implemented to counteract this would be using a fingertip scanner, facial recognition system, or an iris scanner, all those associated with someone who has the proper authentication.
So you must be wondering if there's any concerns or issues associated with the system, and we have done a brief risk assessment, and most of them are related to issues surrounding machine learning and it correctly identifying, for instance, the bounding boxes in which the area in which the information is written, and what would happen if the information was to be written outside of the bounding box, and of course, illegible or complex handwritings which might not be recognized by the system. However, these can be solved via machine learning by supervised learning training a model. And what that means is that there would be an individual who would at some point recognize these things, for instance, the limits of the bounding box or the illegible handwriting, and the model would understand this and in future be able to recognize it correctly. And all of this is actually a pretty reasonable and modest cost estimate. So the tablets that we're going to use will be Apple tablets, and they will cost about 800 euros each. The processor and software license will be about $6,800, which is for the Amazon Web Services or Firebox, as my colleagues mentioned, and a stack light to alert the the operators, to say, okay, this machine is working properly or it's not working properly, which will be about $1,200. And so the cost for one substation will be 8,800 euros. And for 5 substations, along with our installation and commissioning services, will be 62,000 euros. Sorry. Moving on. So we believe that we will be able to execute this in a timeline of 6 weeks, with 1 week for our kickoff meeting and initial review of the scope and a site review. It will take us about 4 weeks for installation, getting all the sensors on there, distributing the tablets, making sure that everything is installed as it should be, and then 2 weeks for commissioning, qualification, and validation activities to make sure that everything is running fine, everything is installed properly, and finally 1 week of training to make sure that the personnel who will actually be using the software are comfortable with it, they know how to troubleshoot any issues if they come up, and they know who to contact. In the future, as perhaps the machines improve and there is a larger budget to spend on these kind of improvements, sensors on all machines, a PI system which will automatically upload data onto the cloud, corrective action operator feedback, which may prompt the operators if they input any incorrect information, further training opportunities, and any additional smarters, proximity training, and of course, Industry 4.0 Smart Factory. And that is all from us. Thank you so much. So the 5 of us that you see over here today, we're not the whole team. Joel also helped with the software stuff. Tran, Etchi also helped with the solution design. And obviously a great thank you to our coaches, Eamon, Thomas, and Michael. They were huge help. If you have any questions, you can send us a Slack message. Thank you so much.